Hello guys, welcome back. So here we have another question from GATE EE 2023 on network theory. So in this question, the admittance parameter of the passive resistive two-port network shown in the figure are. So here is the figure. So we have a two-port network whose admittance parameter is given and the power delivered to the load resistor RL in watt is. So they're asking the power delivered to this load resistor RL. So if you take a look at the circuit, you might start to think that this is similar to having one two-port network here, and this 3 ohm is like acting like another two-port network. So it is like kind of coming in parallel. So you might be trying to recollect the formulas for how does the admittance parameter work for two parallel two-port networks and all. So you no need to go so much complex and complicate yourself or try to remember everything. So this is very easy to solve, and let us just solve it from our basic principles. Okay, so first I take this. So for this two-port network, I will define my V1. So this is my V1, this is my V2, right? And this is going to be my I1 and this will be my I2, and my Y admittance parameter is given. So how will I relate V1, I1, I2, V2? So basically admittance parameter is relating my input and output current, so II, to my input and output voltage, right, in matrix form. So if I were to write it, I'll get I1 is equal to Y11 V1 plus Y12 V2, and I2 will be Y21 V1 plus Y22 V2. So from here, can we get the Y11, Y12 formulas? So my I1 is equal to 5V1 minus 2.5V2. Similarly, my I2 is equal to minus 2.5V1 plus V2, right? Okay. So now from this circuit, what can I say about my V1? V1 is my this voltage, which is equal to 20 volt, right? So my V1 is known, and this node are V1 and V2. So what will be the current flowing in this 3 ohm? It will be V1 minus V2 by 3 ohm, which is 20 minus V2 by 3. That is the current flowing here. I'll call it some I, okay? And what will be the current flowing here? Here you know that the voltage is V2. So this current is V2 by RL, which is nothing but V2 by 6 ohm. So V2 still we have to find. So basic idea is if I know V2, then my power across RL is V2 square by RL. So I need to find out V2, okay? So from this, at this node, if I were to write a KCL, what will I get? I'll get my I is equal to I2 plus V2 by RL. I2 I can get as I minus V2 by RL. My I is nothing but 20 minus V2 by 3 minus V2 by 6. This is my I2. So if I were to multiply both sides by 6, I'll get 40 minus 2V2, and here I have minus V2. So 40 minus 3V2. So this is one equation. And here from this, if I were to write down V1 value, I'll get I2 is equal to 20 into 2.5. How much is it? 20 into 2 is 40, plus 0.5 into 20 is 10. So minus 50 plus V2. So these two equations, I can eliminate I2 and find V2, right? So 6I2 is equal to 40 minus 3V2. Similarly here, 6I2 is equal to minus 300 plus 6V2. So I'll subtract. So I'll get 0, 340 minus 9V2. So my V2 is equal to 340 by 9, right? Now my PRL is equal to V2 square by RL, which is 340 by 9 whole square into 1 by 6. So let us try to calculate this using a calculator. So this value comes out to be 237.86. Okay, so this is my answer. So that is why whenever you see a question, you try to remember your basics. That will be sufficient. So with basics, you can try to solve as many questions. Maybe it will take a little longer, but GATE, you will still have sufficient time to complete all the question, even though you're solving it very on a theoretical basis without remembering formulas. Okay.